Have you ever, like, looked up at the night sky and just been completely mesmerized by those rings around Saturn?
Oh, yeah.
I mean, they're just stunning.
They're incredible.
But also this huge cosmic puzzle.
Yeah.
Like, imagine a band of ice and rock so massive that it could stretch between the Earth and the Moon.
Wow.
But at the same time, it's as thin as a sheet of paper compared to the vastness of space.
Right.
That's what we're talking about here, Saturn's rings.
Exactly.
And today we're going to take a deep dive into the heart of this celestial mystery.
Welcome to Cosmos in a Pod Space and Astronomy series.
So let's start with something simple. What exactly are these rings even made of?
Okay, well, picture this. Vast, flat bands of ice rock and dust all swirling around Saturn's equator.
Okay.
They're mind-bogglingly huge, spanning roughly 273,000 kilometers across.
Wow.
Like a giant icy frisbee in space.
Okay.
But here's the catch. They're incredibly thin,
Okay.
averaging only about 10 meters thick.
Wow, that's like spreading a whole mountain range into a thin sheet. That's hard to wrap my head around.
It's incredible.
What exactly is making up this cosmic frisbee?
Well, the main ingredient is ice.
Yeah.
About 95% water ice, to be exact.
Wow.
And that's why they shimmer and gleam so brightly, reflecting sunlight back to us here on Earth.
Right.
But it's not all ice. There's a sprinkle of rock and dust mixed in.
Uh-huh.
And get this, even traces of organic molecules.
Wait, organic molecules, you mean like the building blocks of life?
Whoa.
Does that mean there could be, life in those rings?
Hold on.
Okay.
It's not that straightforward.
Okay.
Finding organic molecules doesn't automatically equal life.
Right.
But it does raise some really intriguing questions.
Okay.
It's like finding a clue in a cosmic detective story.
I like that.
It hints at the possibility that the ingredients for life could exist in other parts of our solar system.
Okay, so we've got this massive, thin, sparkly disk made mostly of ice with a dash of rocks and a sprinkle of these mystery molecules. Yeah. But how did it even get there? How did Saturn's rings even form in the first place?
That's the million-dollar question.
Right.
And it's one that scientists are still grappling with.
Yeah.
There are a few compelling theories, though.
Okay.
One of the most popular is the destroyed moon theory.
Okay.
Imagine a moon getting a little too close to Saturn
Uh-huh.
and being ripped apart by the planet's immense gravitational pull.
Oh, wow.
The shattered remains could have then spread out, eventually forming the rings.
Wow. Talk about a dramatic origin story. Are there any other contenders in this cosmic whodunit?
Absolutely.
Okay.
Another possibility is what we call primordial rings.
Okay.
The idea here is that the rings are actually leftovers from the early solar system,
Okay.
material that never quite coalesced into a moon.
So, like, they never actually got to be a moon?
Exactly.
Wow.
It's like finding ancient relics from the birth of our planetary neighborhood.
Oh, that's cool.
And then there's the comet or asteroid collision theory.
Mm.
This one suggests that a massive collision created a debris field that eventually settled into the rings we see today.
Okay.
And lastly, we have the episodic formation theory, which proposes that it wasn't just one event, but a combination of processes.
Oh, so like multiple things.
Exactly.
Okay.
Like moon disruptions and impacts happening over millions of years.
So it's like a cosmic mystery with multiple suspects.
Yes.
And we're still trying to figure out who did it.
Exactly.
But here's another question that's been kind of bugging me.
Okay.
Why are Saturn's rings so prominent compared to the rings around other planets?
Yeah.
What makes them stand out so much?
That's a great question.
Yeah.
And it comes down to a few key factors.
Okay.
First off, location is everything.
Okay.
Saturn's rings lie within something called the Roche limit.
The Roche limit.
Yeah, think of it as a boundary around a planet,
Okay.
where its gravity prevents a moon from forming.
Okay.
The ring material is caught in this delicate balance, constantly pulled apart, but never able to clump together into a moon.
So they're always kind of being pulled, but they can never actually come together.
Right. It's stuck in this kind of cosmic dance,
Yeah.
constantly being tugged and pulled, but never quite able to escape.
So,
Another factor is the makeup of the rings.
oh, yeah.
That high water ice content we talked about earlier
Right.
makes them incredibly reflective.
Yeah.
So they bounce back sunlight like a giant cosmic mirror,
Wow.
making them appear exceptionally bright.
So they're perfectly positioned and made of the right stuff to just put on a dazzling show for us.
Exactly.
But hold on, isn't there something about Saturn's moons having a hand in all of this too?
You're absolutely right. It's not just about location and composition.
Uh-huh.
Saturn's moons play a crucial role in shaping and maintaining those rings.
Right.
Yeah, it's like a celestial ballet with the moons influencing the ring's structure and behavior.
Okay, now I'm really intrigued.
Mm-hmm.
Tell me more about this cosmic dance between the rings and the moons. What kind of influence do they have?
Think of the moons as cosmic choreographers.
Okay.
Guiding the ring particles.
Uh-huh.
Some small moons, called shepherd moons, act like guardians,
Okay.
keeping the ring particles in line with their gentle gravitational nudges.
Okay.
These little shepherds, like Pan and Prometheus, orbit within or near the rings, subtly shepherding the particles and preventing them from spreading out too much.
So they're like the sheepdogs of the solar system, keeping those icy particles in check.
Precisely.
That's awesome.
Then we have the larger moons,
Okay.
like Mimas,
Yeah.
that create those stunning gaps in the rings.
Right.
They do this through a phenomenon called gravitational resonance.
Gravitational resonance.
Yeah, imagine pushing a child on a swing.
Okay.
If you time your pushes just right, you can make the swing go higher and higher.
Right.
It's the same with the moons and ring particles.
Oh, wow.
The moon's gravity gives a rhythmic push to specific ring particles, clearing out a path and creating those striking divisions, like the famous Cassini Division.
So it's not just a random collection of ice and rock. There's a whole system at play, with moons acting like sculptors, shaping and molding those rings.
Exactly.
Makes you wonder how much we still have to uncover about our own solar system.
It really does.
And speaking of uncovering secrets, I'm curious to delve into what the Cassini mission taught us about Saturn's rings.
Okay.
This incredible spacecraft spent over a decade orbiting Saturn, sending back a treasure trove of data that revolutionized our understanding of these enigmatic structures.
Absolutely.
What stands out to you as like the most amazing discoveries from Cassini?
Well, Cassini gave us unprecedented views of the rings, revealing details and complexities we could only have dreamed of observing from Earth.
Right.
It's like having a front row seat to one of the most spectacular shows in our solar system.
Cassini was a game changer.
Yeah.
It provided these unprecedented views of the rings, capturing details that were both breathtakingly beautiful and scientifically invaluable. One of the things that just blew my mind was the sheer diversity of the rings. Intricate features like propeller-shaped structures created by tiny moonlets nestled within the rings.
Exactly.
And close-up views of those spokes we were discussing earlier.
It was incredible.
Yeah?
Remember those intriguing organic molecules we talked about?
Yeah.
Well, Cassini confirmed their presence in the rings.
Really?
Providing further fuel for the discussion about the possibility of life elsewhere in our solar system.
That's so cool.
And it didn't stop there.
What else?
Cassini also found evidence of vertical structures within the rings,
No way.
with some areas towering several kilometers high.
Wow.
Icy cliffs and peaks hidden within these seemingly flat structures.
That's incredible. It challenges our entire perception of what rings are and how they behave.
Exactly.
And let's not forget Cassini's grand finale. Those daring grand finale orbits where it flew between Saturn and its rings.
Oh, yeah.
What a way to go out.
It was amazing.
Absolutely.
Yeah.
Those final orbits allowed Cassini to get closer to the rings than ever before, providing incredibly precise measurements of their mass and composition.
Right.
It was a bittersweet ending to a groundbreaking mission.
Yes.
But the data it collected will continue to fuel scientific discoveries for generations to come.
For sure.
It's amazing how these space missions keep on giving even after they've completed their primary objectives.
It is.
But with all that we've learned from Cassini, there must still be unanswered questions about Saturn's rings, right?
Oh, yeah. There are still plenty.
What are some of the things that continue to puzzle scientists?
Well, for starters, the age of the rings is still a subject of debate.
Okay.
While Cassini provided some clues, we still don't have a definitive answer on how old they really are.
So we still don't know.
Not exactly.
Okay, and then there's the fact that Saturn's rings are slowly disappearing.
Right.
It's kind of sad to think about, like, a beautiful sunset that eventually fades away.
It is.
Why are they disappearing?
Well, the main culprit behind their gradual disappearance is Saturn's gravity.
Okay.
The planet's immense gravitational pull is constantly tugging at the ring particles,
Yeah.
slowly dragging them inwards like a cosmic drain.
So it's like this slow-motion cosmic ballet with the rings spiraling towards their eventual demise.
But that's a very poetic way to put it.
This process is accelerated by a phenomenon we call ring rain.
Yes.
Essentially, the icy particles in the rings are constantly being bombarded by solar radiation and micrometeoroids.
Right.
This bombardment creates charged water molecules that get trapped in Saturn's magnetic field lines and
Mm,
pulled into the planet's atmosphere.
exactly.
So it's not just gravity pulling the rings in, but also this constant rain of icy particles falling into Saturn's embrace.
That's right.
Okay, so we know the rings are fading, but how long do we estimate they have left? Like, give us a ballpark figure.
Well, based on current observations and models, scientists estimate that Saturn's rings could disappear completely within the next 100 to 300 million years.
Wow, that's a pretty wide range.
It is.
Why is it so difficult to get a more precise time frame?
The challenge lies in accurately measuring the rate of ring rain
Okay.
and understanding all the variables that influence it.
Mm-hmm.
It's a complex interplay of gravitational forces, magnetic fields, solar radiation,
Right.
and the composition of the ring particles themselves.
So a lot of factors.
A lot of factors.
There's still much we don't know, and that uncertainty leads to a broad range in our estimates.
Exactly.
It highlights the importance of continued research and future missions to Saturn.
Absolutely.
We need more data to refine our models and get a clearer picture of the ring's fate.
For sure.
Well, I think we've given our listeners plenty to ponder for.
I think so too.
We've covered a lot of ground from the ring's composition and formation
Right.
to the influence of Saturn's moons and the groundbreaking discoveries of the Cassini mission.
It's been a great discussion.
But we're not done yet.
Oh, no.
When we come back, we'll delve into some of the latest research and theories about Saturn's rings. And we'll explore the future of these majestic structures. Don't go anywhere.
We'll be right back. Welcome back to Cosmos in a Pod, where we're unraveling the secrets of Saturn's rings.
Before we went on a little pause, we were discussing some of the big questions that still surround these rings, like their age and how long they'll actually stick around.
Right.
It's kind of mind-blowing to think about these massive structures, constantly changing around this giant planet.
It's awe-inspiring.
And as we dive deeper into the research,
Yeah.
we keep finding more intricate details and complexities.
Right.
One fascinating area of study focuses on these strange things called spokes in Saturn's rings.
Spokes?
Spokes. I have to admit, I've never even heard of those before.
Okay.
What are we talking about here?
Imagine you're looking at a vinyl record spinning,
Okay.
and suddenly you see these faint lines radiating out from the center, appearing and disappearing like fleeting ghosts.
Okay.
That's kind of what spokes look like in Saturn's rings.
Okay, I can picture that. But what causes these spokes to appear and vanish like that?
Scientists believe that Saturn's powerful magnetic field is the culprit here.
Okay.
Remember, Saturn has an incredibly strong magnetic field,
Right.
and it interacts with the charged particles within the rings.
Mm-hmm.
This interaction creates electromagnetic forces that can lift tiny dust particles above the ring plane,
Okay.
forming those visible spokes.
So it's like the magnetic field is conducting this cosmic light show, creating these fleeting patterns in the rings. That's amazing.
That's really spectacular.
And it gets even more interesting.
Uh-huh.
These spokes seem to follow a seasonal pattern on Saturn.
They do.
As the planet makes its long journey around the sun,
Yeah.
the angle of sunlight changes.
Right.
And this affects the interplay between the magnetic field and the ring particles.
Exactly.
It's like a cosmic clock ticking away in the rings, influencing the appearance and disappearance of these spokes.
That's a good way to put it.
It's mind-boggling to think about all this activity happening out there that we can't even see with the naked eye. It makes you realize how much we rely on these missions like Cassini to get a closer look at these hidden wonders.
It really does.
Speaking of shows, I have to bring up the fact that Saturn's rings are slowly disappearing.
Right.
It's kind of sad to think about a beautiful sunset that eventually fades away.
Yeah, it's bittersweet.
Why are they disappearing?
Okay.
And how long do we have until they're gone?
Well, the main culprit behind their gradual disappearance is Saturn's gravity.
Okay.
The planet's immense gravitational pull is constantly tugging at the ring particles, slowly dragging them inwards like a cosmic drain.
It's like a slow-motion cosmic ballet with the rings spiraling towards their eventual demise.
That's one way to put it.
This process is accelerated by a phenomenon we call ring rain.
Yeah.
Essentially, the icy particles in the rings are constantly being bombarded by solar radiation and micrometeoroids.
Right.
This bombardment creates charged water molecules that get trapped in Saturn's magnetic field lines and pulled into the planet's atmosphere. So it's not just gravity pulling the rings in, but also this constant rain of icy particles falling into Saturn's embrace.
Precisely.
Okay, so we know the rings are fading, but how long do we estimate they have left? Give us a ballpark figure.
Well, based on current observations and models, scientists estimate that Saturn's rings could disappear completely within the next 100 to 300 million years.
Wow, that's a pretty wide range.
It is.
Why is it so difficult to get a more precise time frame?
The challenge lies in accurately measuring the rate of ring rain and understanding all the variables that influence it. It's a complex interplay of gravitational forces, magnetic fields, solar radiation, and the composition of the ring particles themselves.
Right, so a lot of factors.
There's still much we don't know, and that uncertainty leads to a broad range in our estimates.
It highlights the importance of continued research and future missions to Saturn. We need more data to refine our models and get a clearer picture of the ring's fate.
Absolutely. Every new piece of data brings us closer to unraveling the secrets of these enigmatic structures. It's like piecing together a cosmic puzzle, one observation at a time.
Well, I'm eager to hear about those future missions and what they might uncover. But before we dive into that, I think it's time for another quick break. When we return, we'll explore some of the amazing images and discoveries from the Cassini mission, and we'll delve into what the future holds for our understanding of Saturn's rings. Stay tuned. Welcome back to Cosmos in a Pod. We've been on this incredible journey today exploring the wonders and mysteries of Saturn's rings, from their composition and formation to the role of those shepherd moons and the eventual fate of these structures. It's been a wild ride.
It has been fascinating.
And as we've been emphasizing, one of the key players in unraveling these mysteries has been NASA's Cassini spacecraft.
Oh, for sure.
It spent 13 years orbiting Saturn, sending back this incredible wealth of data that has just revolutionized our understanding of these enigmatic rings.
It's incredible.
Cassini was like our eyes and ears at Saturn for over a decade, capturing images and data that have just left scientists in awe.
Yeah.
What were some of the most remarkable discoveries it made?
Well, Cassini provided us with these just unprecedented views of the rings,
Right.
revealing details that were both breathtakingly beautiful and scientifically invaluable.
Yeah.
One of the most striking revelations was the sheer diversity of the rings.
Okay.
We saw these intricate features like those propeller-shaped structures carved by tiny moonlets embedded within the rings.
Like,
And we got a close-up look at those enigmatic spokes we were discussing earlier, witnessing their fleeting dance across the rings.
I remember seeing those images for the first time.
Yeah.
It's incredible to think that those delicate patterns are shaped by forces we can't even see with the naked eye.
It's amazing.
What else stands out to you from Cassini's treasure trove of discoveries?
Well, Cassini also provided compelling evidence for the presence of those organic molecules we talked about, adding fuel to the discussion about the potential for life in other parts of our solar system.
That's cool.
And it didn't stop there.
Okay.
Cassini also revealed vertical structures within the rings,
Wow.
towering several kilometers high.
Really?
Imagine that icy cliffs and peaks hidden within these seemingly flat structures.
That's mind-boggling. It really makes you question our initial perceptions of what rings are and how they behave.
Right.
And of course, we can't forget Cassini's grand finale, those daring grand finale orbits where it flew between Saturn and its rings.
Oh, yeah, the grand finale.
A fitting name for a mission that ended on such a high note.
For sure.
Those final orbits allowed Cassini to get closer to the rings than ever before,
Right.
providing incredibly precise measurements of their mass and composition.
Yeah. And it was a bittersweet moment, knowing that Cassini was nearing the end of its incredible journey.
Right.
But the data it gathered during those final orbits will continue to inspire and inform scientific research for generations to come.
It's a testament to the enduring legacy of these space missions. They keep on giving, even long after they've completed their primary objective.
Yeah, they really do.
But as much as Cassini has taught us, there's still so much we don't know about Saturn's rings.
Yeah, for sure.
What are some of the big questions that future missions can help us answer?
Well, one of the most persistent questions is the age of the rings.
Right, we still don't know exactly how old they are.
Cassini provided some clues, but we still don't have a definitive answer.
Yeah.
Are they ancient relics from the early solar system, or did they form more recently from a catastrophic event like a moon being torn apart?
Right.
Further analysis of the ring's composition, particularly the amount of dust accumulation, can help us solve this puzzle.
And I imagine we'll continue to learn more about that intricate dance between the rings and Saturn's moons.
Oh, yeah, definitely.
Especially those shepherd moons that play such a vital role in shaping the ring structure.
Exactly. Future missions could provide us with even more detailed observations of those interactions, helping us understand how the moons influence the ring's evolution over time.
That would be amazing.
Yeah.
And what about, what lies beneath the visible surface of the rings?
Oh, that's a good question.
Cassini's radar observations hinted at this complex internal structure.
Right.
with variations in density and composition.
Yeah, future missions equipped with more advanced radar instruments could give us a much clearer picture of what's hidden beneath those icy layers.
It seems like with every new discovery about Saturn's rings, more questions emerge.
It always seems to happen that way.
It's a constant cycle of exploration and revelation, which is what makes science so captivating.
It really is. Each new piece of data, each new observation brings us closer to understanding the intricate workings of our solar system and the universe beyond.
Well said. And on that note, I think we've reached the end of our deep dive into the mesmerizing world of Saturn's rings. It's been a privilege to explore these cosmic wonders with you, and I hope our listeners have enjoyed the journey as much as we have. Be sure to follow and subscribe to Cosmos in a Pod for more deep dives into the mysteries of space and astronomy.
And don't forget to check out our YouTube channel for stunning visuals and behind-the-scenes content related to today's episode.
Until next time, keep exploring the cosmos.